Hey, hello, you're welcome to my channel. Now here we want to integrate the cosine of cube x dx. Now here I'm just going to go ahead and split that into cosine square x and cosine x. It's actually going to give us the same thing, right? Yeah, I'm actually going to split this so that we can know how to solve this. Okay, so this is how it goes. I have integral of cosine of square x and cosine of x to complete the cube, alright? And I just put down the dx like this. Well, here, I can just go ahead and rewrite this cosine square x using a trigonometry substitution for it, which is just 1 minus sine square x. So I'm going to have integral of 1 minus sine of square x. Okay, in place of cosine square x, I just put that like that, and I then multiply with cosine x again, dx. So I have not changed anything. I'm just doing a trigonometry substitution. Okay. Now, if I multiply cosine throughout in the bracket, I'm going to have integral of cosine x. You know, cosine x times 1 is just cosine x. And again, minus this sine square x times cosine x. I have it sine square x cosine of x. And this is just dx. Well, from here, I can just go ahead and split the integrals. You know, we're having the integral of the difference of two functions of x is going to be the difference of the integrals. Like integral of cosine of x, this is integral sign, not s, right? Yeah, minus integral of sine of square x, cosine of x, and dx. So this is actually dx here. If you don't put this, you are not doing anything, because you are showing that this x is a variable of integration, this particular x here. Okay, so it shows the variable you are integrating. In a situation where you will be having in a function of more than one variable. So you just use this one to tell us which one you are integrating at that time, alright? Okay, so strictly, the integral of cosine x is just sine x, positive sine x. Positive sine x. So you just have it there to be positive sine x. And we want to integrate this, sine square x and cosine of x. Integral of sine of square x and cosine of x. In fact, let me just clean it. Where's my duster? Let me just clean this up so that I will integrate this right here. Let's show you how to integrate integral of sine of square x, then cosine of x dx over there, right? Let u be equal to, if I call u sine of x, if I make that to be my u, then by differentiating, you know, by change of variable, by differentiating the sine of x, I'm going to have the u, the x that is differentiating u with respect to x. So the u dx is going to give me cosine of x. You know, I'm having the u dx, so I can multiply the x on both sides, and I don't have the dx here, so the u becomes cosine of x dx. So here, you can see here that we have cosine of x dx. So that can replace, so the u can replace cosine of x dx, because the u just equals to cosine of x dx, and in place of sine square x, you just put the u squared. So we have integral of u squared du. This is just going to lead us to using a power rule, where we're just going to have u cubed over 3, okay, where u is sine x, so we have sine of cube x over 3, and this is the integral or the antiderivative of this function. So we just plug it in here. We're going to have sine of cube x over 3. This is cube as a power. Okay, so here we are just done with the integrals, and we just put a plus c. So this is the antiderivative of cosine of cube x as given above. Okay, thanks for watching, and please subscribe to this channel.